Welcome to Transmission Podcast. I'm your host, Cecilia Lynn Jacobs. For the next little while, we invite you to speculate on the possibility of life on Proxima b, the closest known planet outside of our solar system that has the potential to support life. In each episode, we question what would happen if we suddenly knew we were no longer alone in the universe, and what that would mean for humanity to become an interstellar civilization. Please, stay close. April 12th, 2017, Transmission Podcast hosted a live show in Edinburgh, Scotland, as part of the Edinburgh International Science Festival in the National Museum of Scotland. We spoke with returning guests Doctors Beth Biller, Duncan Forgan, Pippa Goldschmidt, and new guest William Taylor, who is also based at the Royal Observatory at the University of Edinburgh. Stay close as we share that conversation with you now.
So I'm really looking forward to this talk today, actually. There's some fantastic and really interesting discussions that have been happening even before we opened the doors. So I would like to introduce our chair for this evening. She's going to guide us through the talk today, and then we'll have a short Q&A afterwards as well. So I'd like to hand over to Cecilia Lynn Jacobs, who is the podcast host of Transmission.
Great. Hi, guys. Okay, it's wonderful to have you here this evening. I'm actually going to do what I can to step kind of out of the way because I'm sitting with really lovely, accomplished and fascinating humans. So, don't just stand there and live up to it. But I'll start with you, Beth, and if you could just go down the line, you'll say who you are and what you do. And then afterwards we can talk a little bit about how you guys know each other.
All right, my name is Dr. Beth Biller. I am in fact a human. I am a reader at the University of Edinburgh, and I'm an astrophysicist, and my particular specialty is direct imaging of exoplanets. So essentially taking pictures of planets around other stars, which we actually have done for big things larger than Jupiter, but eventually in the far future we're hoping to take pictures of planets like the Earth.
Okay, I'm Dr. Duncan Forgan. I'm also an astrophysicist. I'm a research fellow at the University of St Andrews, and my work is theoretical, so I'm looking at the process by which planets are actually assembled around stars and how those planets become suitable for life, and also how we can search for intelligent life on those planets.
I'm Dr. Pippa Goldschmidt. I used to be an astronomer some years ago here at the observatory. I left academia and then I joined the UK government as a policy advisor, and on and off for a few years worked in the area of space policy, in particular around the regulation of outer space. And I'll say a little bit more about that later and what that actually means in practice. I'm now a writer. I'm a writer of literary fiction that engages with science, particularly physics and astronomy. And I have a sort of visiting fellowship here at the Social Sciences Department at the University of Edinburgh.
I'm Dr. William Taylor. I work at the UK Astronomy Technology Centre, which is also based up at the observatory on Blackford Hill. I'm a bit of I'm an astronomer who wants to be an engineer, really. So I spend most of my time working with engineers on designing new bits of equipment which go to telescopes, generally ground-based telescopes. I actually am not an exoplanet researcher at all. I look at massive stars which don't have planets around them, but I build the cameras and spectrographs and things which you would use to look at and study the planets.
So we've actually gathered you guys here as a part of our ongoing work on an Edinburgh Fringe Festival show called Transmission. It is a show about first contact. It is a distributed reality performance, which means that you can go all about the city and collect different pieces of the story at different points. But as a part of our research, we were having such fascinating conversations that we decided to make an entire podcast series about it as a way to share that information with whoever's interested. And I know that you guys are all connected to each other. I know that you guys are working on a project right now. Do you want to talk a little bit more about how you met and who knows who and that kind of thing?
Sure. So I've worked directly with both Duncan and with Will. So Duncan has worked theoretically on planet formation, and I work on observations. I've worked on large-scale surveys looking at lots of stars, trying to find planets around those stars by directly imaging them. And actually, unfortunately, not finding a whole lot of them. Duncan kindly produced simulated populations of the sort of planets we'd expect to see at wide separations. And combining Duncan's simulated populations with the surveys that I've been working on, we were able to essentially statistically show that giant planets were pretty rare, actually. So, useful paper, maybe not the result we had originally wanted. And we're working on extending this work for new planet surveys as well. So that's how I've been working with Duncan. And this has been going on for what, about 3 or 4 years now?
Yeah, about that, yeah.
And Will works on new instruments, and one in particular I've been working on as well. It's called ERIS. So it is a new imager for the very imaginatively named Very Large Telescope. Does ERIS actually stand for anything?
Yeah, it does. I should know what it is. It's Enhanced Resolution Imager. Or
maybe Enhanced Resolution Imaging Spectrograph?
Yes. Astronomy is full of awful acronyms. It's just disgraceful. I think the Very Large Telescope, or the VLT, is one of the worst examples.
It's like sausages, you really don't want to know what's in them.
Yeah.
Yeah, so ERIS is a very interesting new instrument because it's going to be able to image planets at longer wavelengths than we've been able to do before. So most of the planets that we've imaged so far have been imaged mostly in the near-infrared, and ERIS is going to push to the mid-infrared, which interestingly, for smaller planets, is where you might look for a lot of biosignatures.
Wait, I'm sorry, a mid-infrared?
Oh yeah, okay, I'm jargon again. Yeah, sorry about
I'm just going to be, I think probably my primary role is going to be like, I don't know what that means.
Most planets that we've imaged to date, we've imaged at wavelengths of about 1 to 2.5 microns. Mm-hmm. So this is longer than what you can see with your eyes.
Okay.
And if you could look at these wavelengths at everyone in the room, you'd be glowing, pretty much, because it's close to our black. So if you've ever seen an image from an infrared camera, your face will glow, everything will glow. And it's because it's about the peak of the black body of the temperature that we're at.
Okay.
So then the mid-infrared is further on. So in this case, I'm talking more like beyond 3 microns up to maybe 10 microns. Mm-hmm. Everything is glowing even more at those wavelengths. Okay, great. So it's hard to do from the ground.
Yeah.
And ERIS is going to be a very interesting instrument because it should be able to do this.
Mm-hmm. Wonderful. Okay, great. And then so you and Beth are working together, and then you know William, I believe, from a different project?
Well, the reason I know Will is because we actually did our PhDs at about the same time. So my PhD was at the Royal Observatory here in Edinburgh, and I was a postdoc at Edinburgh for about 4 years, so doing research post-PhD, and Will was a year behind me. So that's how I know Will.
Yeah, we know each other from drinking coffee, primarily.
Yeah, so that's where I know him from.
Saying, how are things going? I would generally sit there stressing Duncan would have written a paper during the day. So,
you're being too kind. Yeah. And Pippa and I met while Pippa was visiting the observatory during her sort of current phase as a writer, while I was still a postdoc there. So that's how I met Pippa. And obviously, Beth and myself have worked and are continuing to work together and taking the kind of theories that I have about how planets are formed and then putting them to the test by actually going out and trying to find what I predict is there.
Great. Cool. And then
So, I was a writer in residence at the observatory in 2013, and I was based there for the year writing short stories inspired by real science, which is primarily what I do. So, for example, one of the stories I wrote was about the suffragette bombing of the observatory in 1913. This is something that people here know about. So, in May 1913, the suffragettes targeted the observatory and placed a bomb, I think think at the base of the West Tower, and it blew up and did a fair amount of damage. So not much is known about the reasons behind that bombing, why the suffragettes targeted the observatory, although we can sort of speculate it could be because it was a very sort of male-dominated institute at that time, although there were a few women who worked there. So I wrote a short story sort of inhabiting that gap in the historical records, and that's quite sort of typical of what I do. So when I was there, I had a lot of chats with the actual astronomers, trying to sort of tease out a lot of what they did, so I could sort of use it in a sort of rather parasitical way in my stories, in my novels, and so on.
And then, do you have anything to add? You're at the end of the line, so
Yeah.
Okay.
Yeah, probably fine. Yeah.
That's lovely. I'm going to launch into some questions that we've gone over quite a bit, but parts of the information that we're gathering for transmission is research, because transmission is a play about first contact. In our story world, we and the cast of characters have received transmissions from around Proxima B, which is a planet that Beth can tell you actually quite a bit about. And we're exploring the social likelihood of what would happen if we really did start getting fairly consistent broadcasts from a different intelligent civilization. And so that's kind of the basis of where these questions are coming from. And the first one is, how do we listen to space? And we can kind of check in, but I know that everybody has a different perspective on this, and we can just kind of talk to each other about that. And Beth, if you'd like to start, I know that's what you do.
Yeah, that's true. Oh, actually, can I go back to Proxima Centauri?
Yeah, please.
Actually, that may be a good starting point. Just
some
how
background.
We study things in space.
Of course.
So who's heard of Proxima Centauri b? Who's heard of the TRAPPIST planets? Well-informed audience. So these are the closest known, potentially, and the potentially is very important here, habitable planets. And Proxima Centauri b is actually the closest star to the sun, period. And TRAPPIST-1, the star, the 7 other planets around, is not terribly far away from us either. So these planets are essentially roughly the right distance from their star that they could potentially have liquid water on their surfaces, and they're not too large that this would be a situation where you absolutely would not have a solid surface or have a potential habitability. So now you might ask me, how do you know that? And like with everything else in astronomy, we know this because we study light. Other than a bit of gravitational wave detections, everything we do, and maybe neutrinos as well, but otherwise everything we do in astronomy is just studying light from objects. And there's a huge diversity of ways you can study light from objects. You can just take pictures of things. You can disperse light and get a spectrum as well, so essentially a rainbow of your light, and study that. So that tells you a lot about the composition of objects, because different molecules or atoms will absorb that light at different wavelengths. Those are the two main things, but you can also study how the star is moving on the sky. You can study how its brightness might change. But again, it all goes back to light. So when we study exoplanets, there's a variety of different ways we can untangle the fact that they're there from the light that we get either from the star or the planet itself. It might be, this is not too long-winded, is this?
I don't think so. If people have a spot to jump in, then just go for it. Yeah.
Can I touch on your use of habitability?
Yes.
We talk about planets being in a habitable zone, and this is an interesting point just generally in terms of when a lot of news stories related to habitable planets. I heard somebody arguing the other day that we should talk about the not completely inhabitable zone rather than the habitable zone, because we define this habitable zone as an area in which you would get liquid water on the surface, but that doesn't necessarily mean that there's going to be life. There's a non-zero chance, but it's probably much nearer to zero than it is anything else.
Yeah, this is one of my classic bugbears. This idea of saying that if you get a planet and it's in the habitable zone, then it's a slam dunk, and it's going to be habitable, and it's probably going to be inhabited. If it was up to me, the phrase habitable zone would be banned because it doesn't tell you what's actually happening. What the habitable zone is doing is saying, if you take a planet that's exactly identical to the Earth, so it has the same mass, has the same radius, It has the same properties in terms of the crust and the mantle and the core and all that helps you generate the magnetic field. And it has the same atmospheric composition. So you basically clone the Earth, put it around this star, and there are a range of distances around which the water on that Earth clone's surface will be liquid. Now,